Welcome to the video lecture series Microprocessor and Microcontroller. My name is Dr. Anilesh Day, Associate Professor, Department of Electronics and Communication Engineering, Narula Institute of Technology. This is lecture 22. In this particular lecture, I first emphasize on the topic flag register of 8086 microprocessor. We know that in 8086 microprocessor, the register contained the 16-bit. So flag register also contained the 16-bit. This is the D0 bit and this is the D15 bit, and this is the total 16-bit flag register. Within 16-bit flag register, the 8-bit D0 to D7 just similar to 8085 microprocessor. CF stands for carry flag, PF stands for parity flag, AF stands for the auxiliary carry flag, Z for the zero flag, S for the sign flag. I already discussed in this topic in the 8085 microprocessor. Now these are four at the new flag. O stands for overflow flag, D stands for direction flag, I transfer interrupt flag, T transfer trap flag. First I go for the direction flag. This is used by the string manipulation instruction. If 0, string is processed beginning from the lowest address to the highest address, that is auto incrementing mode, otherwise auto decrementing mode. That means if 1, then it is going for the highest to lowest address. Interrupt flag. This flag is set the maskable interrupt are recognized by the CPU, otherwise they are ignored. Trap flag. If this flag is set, microprocessor enters into single step execution mode. What is the meaning of the single step execution mode? You can go for one step, check that step, and then execute that step. A trap interrupt is generated after execution of each instruction. The processor executes the current instruction and the control is transferred to the trap ISR. Overflow flag. This flag is set if an overflow occurs. That is, if the result of a signed operation is large enough to accommodate in a destination register. For example, in case of addition two signed numbers, the result overflows into the signed bit, that is result is of more than 7-bit in size, and in case of 8-bit signed operation and more than 15-bit in size in case of 16-bit signed operation, then the overflow flag will set. So this is about the flag register of the 8086 microprocessor. Then I go for the physical address generation. We know that in 8086 microprocessor, address bus is 20-bit and data bus is 16-bit. So all the register sites is also the 16-bit. So the complete physical address, which is 20-bit long, is generated within the segment and offset register, each the 16-bit long. For an example, I have the segment address that is a 1055H. And I have an offset address 5555H. With the combination of this segment address and offset address, I generate the physical address. How? First, this is my segment address 1055H. I have written in binary form and shifted the segment the 4-bit position. That means this bit is shifted over here, this is shifted over here, this shifted over here, and finally this is shifted over here. So this vacant position is occupied by the 4 zeros. So I'm indicating that thing in the red color. Now this is the offset address, that is the 5555H. I'm adding these two data, and this is the 15A5H. So this is the physical address generation with the combination of the segment address and offset address. So I'm concluding this subject topic in this way. Physical address is nothing but the segment address multiplied with the 10 plus offset address. That means the shifting of the 4-bit left is nothing but the multiplied with the 10. So that is the segment register multiplied with the 10. So 1055H is multiplied with 10, that is the 10550H. Then it is added with the offset address and generated the physical address 15A5H. Now I'm discussing the architecture of the 8086 microprocessor. I discussed in the pipelining architecture that the architecture is divided into two parts. One is called the bus interface unit BIU and another is called the execution unit EU. This bus interface unit is responsible for the fetch the instruction and this is responsible for the decode and execute the instruction. Now I take an example. There is the three memory location starting with the 20,000 H. There is the first data will stored. Second one the 20,001 H. The second data is stored. I'm adding these two data and finally stored the result is a 20,003 H. So how 20,000 H is generated? That's a combination of the segment register. This is code segment, data segment, stack segment, extra segment. You can choose the code segment register value is a 2000 H and IP address is the 0000H. Now this value is coming from here to the address conversion mechanism. First the segment register value over here and IP through the help of this internal data bus coming over here. So with the help of the physical address generation mechanism, segment register multiplied with the 10 and added with the offset value generate the 20-bit address. Now this 20-bit address from here through this data bus is coming over here. It is reading the memory address and data bus interface. Now here find it out that address and data bus here the multiplexed order AD0 to AD15. Now I want to demultiplex that thing with the help of the ALE signal. Control signal is generated by this. It will demultiplex and this is also available A16 to A19. So right now 20-bit address bus is available and address value is placed on the 20-bit value where the first data is stored. Now from there again it is generated the control signal read, so data is placed on the data bus and coming over here to the internal location come to the 6-byte instruction queue. It is a 6-byte long. First two data is coming over here. And why we can keep the 6-byte instruction queue? Because when microprocessor face first instruction and it is transferred for the decode and execution for the execution unit, the second data is fed. So why do you keep the second data? For that this instruction queue to taking the second data. So similarly, first data coming to the execution unit come over here. This is the AX combination of the AH and AL. Similarly, BX, CX, these are all at the general purpose register. This is two pointer register, source pointer, base pointer, and two index register SI and DI. First data will coming over here. Similar way, we can generate with the help of the segment register and IPs locate the second location where the second data is stored. Again, it is generate the control timing control signal is during the read operation. Second data will coming through here and stored in the instruction queue. And through this internal bus come to the second register. Now from there, these two data is coming to the ALU, perform the task of the arithmetic operation and corresponding flag will set. Now data is in the processor. I want to send the data to the memory location again with the help of the segment and offset address and generate the physical address 20,003. And then microprocessor locate the memory location with the help of the address bus where we want to send the data, timing and control signal, generate the WR signal. Now from the ALU, data is through the internal data bus. It is moving out from the processor. In this way, the 8086 microprocessor works. So conclude the architecture in this way: two unit, BIU and EU. BIU for the fetch instruction, EU for the decoding and execution of the instruction, and this is the decoding circuit. This is all about the 8086 microprocessor architecture. Now coming to the next one for the minimum and maximum mode. Why minimum and maximum mode? Minimum mode signal can be directly decoded by the memory and IO circuits, resulting in a system with the minimal hardware requirements. Second one is that maximum mode signals are more complicated but obtain the new signals that allow for the bus grant, example DMA. So this is the pin diagram of 8086 microprocessor. I already discussed all the pins in the when I discussed the pin diagram except the minimum maximum mode pin. This is MX MX bar. When it is 1, it is operate as a minimum mode. When it is 0, it is operate as a maximum mode. When it is 0, the pins for the maximum mode, these pins are working. when it is the one, this minimum mode pins are working. I explain pin one by one. So it is already I explained what is mn/mx bar pin. Minimum mode signal ALE, it is the address latch enable. The output signal indicates the availability of the valid address on the address data bus and is connected to the latches enable input of latches. DEN bar data enable, data bus enable signal indicates the availability of the valid data over the address and data lines. Hold, the hold input request directly access the DMA. If hold logic is 1, the microprocessor stops its normal execution and places the address data control bus to the high impedance state. HLD for the hold acknowledgement signal, WR bar for the write operation, INTFR for the interrupt acknowledgement signal. This is the pins for the minimum mode of operation. Now I explain the pins and this is very important. M/IO bar, I just escape this in. It is a if it is a 1 for the memory operation, 0 for the input output operation. It is a just difference for the 8085. The 8085 there is a IO/M bar, here it is the M/IO bar. So student don't confused over here. It is in 8086 it is the M/IO bar, means that when 0 there is a IO operation. Now it is the maximum mode. First we'll go for the S2 bar, S1 bar, S0 bar. This is for the status line. If there is the 3 lines are there, so 8 combinations are there. When it is 000, it is the function is interrupt acknowledge. 001 read from IO port. 010 write into IO port. 011 for the halt operation. 100 for the code access. 101 for the read memory. 110 for write memory, and 111 for the passive operation. It is inactive operation. Now coming for the QS1 and QS0, QS stands for the queue status. It is basically used for the operation of the queue. If there is a 2 pins QS0 and QS1, so there is a 4 combinations are there. Function is that when it is 00, no operation, queue is idle. When it is 01, first byte opcode from the queue. When it is 10, queue is empty, and when 1, that is a subsequent byte opcode from the queue. Now, next instruction is the lock bar. The lock output is used to the lock peripheral of the system. That is the other system bus master will prevent it from the gaining the system bus. Now RQ bar GT1 bar and RQ bar GT0 bar is RQ and GT stands for the request and grant. These pins are used by the other local bus master force the processor to release the local bus at the end of the processor current bus cycle. These lines are bidirectional and are used both request and grant ADMA operation. So this is all about the maximum mode pins. Now in maximum mode of 8086 system, the microprocessor 8086 operated in the minimum mode by strapping its MNX bar pin logic 1. Some types of chip selection logic may require to selection the memory or IO devices depending upon the address maps of the system. So this is the diagram, and I'm explaining the diagram in the next slide step by step. First one, the latches are generally buffered output D flip-flop like 74 LS373 or 8282. Second one is that they are used to separating the valid address, the multiplex address data signals, and controlled by the ALE signal generated by 8086. Since each has the 20 address lines and 16 database lines, 8086 CPU requires the 3 octal address latches and 2 octal data buffers for the complete address and data separation. Transceiver are the bidirectional buffer, and sometimes they are called the data amplifier. They are required to separate the valid data from the time multiplex address and data signal. They are controlled by 2 signals, namely DN bar and DTR bar. DN bar signal indicates the valid data available on the data bus, while DT/R bar data transmit and receive bar indicates the direction of the data from or to the processor. The system contains the memory for the monitor and user program storage. Usually EPROM are used for the monitor storage, where RAM for the user program storage. A system contains the IO devices for communication with the processor as well as some ideal purpose of IO devices. The clock generator generates the clocks from the crystal oscillator and then shapes it and divides to make it the more precise, so that it can used as an accurate timing reference of the system. It is very important on. The clock generator also synchronize some external signal with the system clock. This is all about and the working of the minimum mode configuration system can be better described in the terms of the timing diagram. So I explain the timing diagram in the later on. So this is the all about of minimum and maximum mode of 8086 microprocessor. So in this lecture, I can cover the flag register of 8086 microprocessor, physical address generation, how the 16 with the help of the 16 bits segment address and offset address, and combined with the help of some logic, we can generate the 20-bit address. Third one is the architecture of 8086 microprocessor, and finally one of the important topic, that is the minimum and maximum mode operation in 8086 microprocessor. This is my contact details. So if any query, write me in my given email address. So it is named of lecture 22, meeting in lecture 23. If you like, then please subscribe my YouTube channel.